Hello and good morning, students. So, in today's class, we'll start a new chapter, that is chapter number 6, Combustion and Flame. So, mainly in this chapter, we'll be discussing about what is combustion, what are the different properties of combustion, what are the necessities for combustion, and your flame, what is known as flame. Okay. So, up to the previous chapter, we have studied about fuels. What are fuels? The things which you use for getting energy, okay, such as coal, petroleum, diesel, kerosene, natural gas, LPG, what we use in our home, that is liquefied petroleum gas, right? So, we get heat, often accompanied by light and burning. So from all these fuel, whatever I say, if you consider just LPG, for example, LPG. So in our house, whenever we burn the gas stove, we get some heat, right? Along with heat, what we get? Along with heat, we get light, right? If you burn a candle, if you burn a gas stove, you will get some light due to the flames, right? So we know whenever we burn these fuels, we get heat along with light. We use different kinds of fuels for various purposes at homes, in industries, and for running automobiles. So this is very common. We know that for different purposes, such as for household activities such as cooking or candles, then for different industrial purposes, then for running automobiles such as car, bike, truck, train. Okay, we use different type of fuels such as petroleum, then your petrol, diesel. Okay, these things. We use coal, kerosene, LPG as fuels of our home. So they're telling that okay, it is known that in our home we use only three things as fuel mainly. These are either coal for a traditional cooking purpose, okay, then LPG for the modern, everyone in our home we have LPG cylinders, and kerosene, okay. Coal, coke, and CNG are used in industries. So in industries, what do you use? We use either coal or coke, which is obtained from coal itself, and CNG, okay. And petrol, diesel, and CNG are used for your automobile purposes, right? Most of in our Assam, most of the cases the automobiles runs on either petrol or diesel, but in some other states such as Delhi or near to our Assam, there is Tripura, right? In Tripura, if you go, there is CNG is very popular. Okay, so for running automobiles, it is car, bike, truck, these things, three types of fuels are mainly used. It is either it is petrol, diesel, or CNG. So we know very clearly that some substance burn and some do not burn, right? You can burn petrol, diesel, then your coal, but at the same time, if I tell you to burn iron or to burn silver, aluminium, you will say that sir, it is not combustible or you cannot burn this. So based upon this property of burning, we can group substances into two groups. That one group is can be combustible, another one is non-combustible. Okay, so some substance like candle and wood burn with a flame, while some substances like coal do not burn with a flame. Again, there are also some subgroup that some substance such as candle and wood, if you burn them, they will give you a flame. Right? Sorry for the interruption. Whereas some substance such as mm, coal, if you burn coal, coal will never give you flame, it will give you heat. So these are some of the properties based upon which we can categorize things. Okay, so what is actually known as combustion? So if you can recall, in the previous chapter, this is chapter number 4, we had done an activity that in which we have, what we did, look at this diagram. We have tried to heat a magnesium ribbon. Magnesium is a metal, so we have tried to heat a magnesium ribbon over a burner, and what it do, it was burned to form magnesium oxide and produce heat and light. So whenever it gets heated, what it showed, sorry, whenever it gets burned, it showed enough heat and it showed us some light. So you can see this diagram also, it is giving you light along with heat. Okay, the same thing we can do with charcoal. With charcoal, what you can do, if we try to burn a charcoal on a Bunsen burner, okay, we are using a burner to burn piece of charcoal, okay. So what we'll do, after some time it will heat, right? If you put the charcoal in a burner, what will do, it will heat, okay. It brings to near the flame of a Bunsen burner. We'll find that the charcoal burns in air, producing heat and light. So wherever the charcoal will burn, it will produce air, sorry, it will produce heat and light. It is very obvious that if you burn something which is combustible, it will produce heat and light. So what is the similarity between these two activities? One, we are saying that burning of magnesium, even another one is burning of your charcoal. When a substance burns, heat is released and some light is also produced. So we know whenever we burn something, for example, you are burning plastic, candle, or your household LPG stove. Okay, so if you burn anything, what will do? The first thing will do, it will produce heat. The next is it may produce light. So a chemical process in which substance burn in the presence of oxygen of air, okay, to give of heat and light, they may or may not be produced, is called combustion. So what is combustion? A chemical process, burning is also a chemical process, right? A chemical process in which substance gets burned and they will produce in the process heat and they may produce light. They may produce or they may not produce. Production of light in the process of burning is not necessary. One may produce, one may not produce, okay, but production of heat is necessary. So those processes are known as combustion. Combustion. Remember the spelling, okay. Burning of magnesium and charcoal, for example, are examples of combustion. So we have seen that whenever we are trying to burn the magnesium or charcoal in the previous experiment, both have produced light and heat also. So we can say that these are combustion process, okay. Since both give heat and light, okay, it is not essential that light must be produced in combustion. Is it clear? In the process of combustion, it is never necessary that light will be produced. If it is produced, that is well and good. It is easy for us to understand. But if light is not even produced, based upon the production of heat, we can categorize into combustible and non-combustible substances. Okay. So moving to the next, what is combustible and what is non-combustible substances? We can categorize all the substances into combustible and non-combustible substances. Everything substance, whatever you know, we can group into two groups. For example, if you burn soil, what will get? After burning soil, you will get nothing but no heat, no light, right? So soil can be considered as non-combustible. If you burn aluminium, what will get? Nothing. It will be heated, but it will not burn, right? So you will get no light, no heat. So it is non-combustible. At the same time, if you burn a candle, what you will get? You will get light, you will get heat. If you burn your gas stoves in home or coal, you will get light, along with that you will get heat. That means for the cases where we get heat and light both, we call them as combustible substances, okay. The substances that burn easily in air or oxygen to produce heat and light, light is not necessary, okay, light may be produced or not produced, are called combustible substances, okay. On the other hand, the substances that do not burn in air or oxygen are called non-combustible substances, okay. The substances which get easily burned in presence of air and produce heat and it may produce light also are known as combustible substances, and the substances which do not burn in air okay, are called non-combustible substances. Examples like materials like petrol, LPG, wax, coal, charcoal, natural gas, kerosene, diesel, all are combustible substances because all of these will give you light and heat. For example, this is example of coal. You are burning coal, you are getting light and heat. Similarly, kerosene, if you burn kerosene, you will get light and you will also get heat. Okay. So now comes types of combustion. How many types of combustions are there? So depending upon the conditions under combustion takes place, there are basically three types. What are these three types? One is rapid combustion, next is spontaneous combustion, and the last is explosion. So as the name suggests, rapid means the process will be fast, right? Spontaneous means it will be continuous for a period of time, right? And explosion means a big explosion type things, right? Suddenly something will happen which will produce large amount of heat, right? So we'll discuss each in detail. So first let us begin with rapid combustion. What is rapid combustion? When a combustible substance burns at a rapid rate, producing a very large amount of heat and light in a short period of time is called rapid combustion. That means when the process of combustion takes place very rapidly. For example, if you try to burn wood, it will take some time. At the same time, if I give you some petrol and if I ask you, okay, burn this, just within 1 or 2 minutes you can burn all 5 liter, 10 liter petrols. That is not a big issue. But to burn 5 kg of wood, you need at least 30 minutes, right? That means in case of petrol the process is occurring very fast. So rapid combustion is saying that when a combustible substance burn at a rapid rate such as petrol, diesel, okay, producing a very large amount of heat. If you burn petrol, diesel, it will produce more heat, right? And light in a short period of time, only within a short period of time. If it does all these things, all the fuel gets burned and it gives you huge amount of heat and light, then it is called as rapid combustion. Okay, the process is occurring very quickly, rapid. For example, cooking gas LPG starts burning immediately when a burning matchstick is brought near it. It produces heat and light. Burning of wax candle is also an example of rapid combustion. For example, they are giving example of our LPG cylinders in our home. Okay, so if I am giving you two example, okay, in the first case you are trying to follow the traditional cooking process in which what you are doing, you are trying to burn woods. So to fix the fire to wood, it will take some time, 5 minutes, 10 minutes. Initially the heat will not be enough, sufficient enough. The first you have to heat the start the heat these woods, okay. After heating the woods, or if the woods are dry, then only slowly the fire will start gaining its more violent form, okay. But what happens in LPG cylinder, you just turn on the cylinder and just take the matchstick near it. What will happen? It will catch fire, right? So we are understanding here that the LPG cylinders burns quickly, right? It catches fire quickly, so we can say that it is a rapid combustion process, okay. So moving to the next is spontaneous combustion. What is spontaneous combustion? The combustion, when a combustible substance burn on its own without the help of any external heat is called spontaneous combustion. So just one step back, on the next last slide we have discussed that to burn the LPG cylinder or calendar, what we need a matchstick, right, or a gas light using which we can burn. So what spontaneous is saying there, to burn something, you do not need any external source such as matchstick or a gas light. You do not need anything here. The fire will catch automatically. So it is known as spontaneous. For example, burning of white phosphorus, then fire in coal mines, then forest fire, example spontaneous combustion. Okay, so phosphorus is a chemical compound. If you bring it into open air, it will automatically start reacting with air, oxygen and other gases, and it will start burning. Moving to the next, in coal mines, sometimes coal get the fire starts. Okay, so this is also a natural phenomenon. Or the next example is forest fire. What happens during summer as the temperature is very high? Okay, so in large forest, due to some natural activities or thundering or some other activities, fire catches into the forest. So human is not doing anything for that purpose. It is a totally natural activity. It is occurring by itself. We are not giving any external energy source such as mastic or gaslight for burning the fire. So these are known as spontaneous combustion, in which no external help is required. And the last is explosion. When a combustion reaction occurs suddenly with the evolution of large amount of gas, heat, light and sound is called explosion. So in explosion, some different angles are added. In this process, what is happening? If a combustible substance combustion process suddenly occurs, and in this process certain amount of heat, okay, heat, light, along with this sound and gases are also released in large amount, are known as explosion. For example, when a light fire cracks, okay, explosion occurs with evolution of heat, light and sound. That means when firecrackers are burned, what happens? It will give you light, it will give you sound, and it will also give you heat. Or if sometimes you have seen that in news channels, people say that okay, explosives, that means a bomb. If you burn a bomb, what will happen? For example, in Diwali also we use firecrackers, right? Common firecrackers, common bombs made for common use. Okay, so these bombs, whenever you burn this, you will get sound, you will get light, you will get some dirty gases over it, carbon monoxide type gas, which will cause pollution, and also you will get heat. So these are known as explosion. So these are the mainly three types of combustion. So if you have any doubt, you can ask me now. Next class we'll discuss further.